Hello. In this video we'll be solving a linear equation. We'll be showing an example of how to do that. Now, let you know at this beginning videos, I may not show you enough examples in my videos to help you throughout the assignment. And if that's the case, that's when you look at the author videos that will be in another tab. So if it's not enough and I can't create all the videos that you might need, but you can also look at the author videos, and if that doesn't cut it, if you still have questions after that, you can also request a video, just like a personal video of a certain issue that you're having, and then I can upload a video for that specific case, or not, just basically another example of what you're referring to, or at least a problem kind of like what you're having issues with. And we will upload that to the course page, and then all students can see that question. So it's on the student request video tab, and as the course grows, those requests will grow, and so more help will be available at those times. Okay, just stay tuned more for those problems. All right, so let's begin this video, solving a linear equation. All right, let's go. Definition. A linear equation is in one variable is an equation equivalent to the form of ax plus b equals 0, where a and b are real numbers and a cannot be 0. You know, well, why can't a be 0? Because if a were 0, then ax would be 0, and that means b would be equal to 0, and so therefore you would not be a linear equation. So they're just qualifying this by saying a can't be 0, but a and b are real numbers. All right. So let's begin with looking at this example here. Solving a linear equation. So solve that equation. We have 1/2 x plus 5 equals minus 4 equals 1/3 times 2x minus 1. All righty. So let's look at that. So here's the solution. All right. To clear the equation of fractions, you multiply both sides of the equation by 6, which is the least common denominator. Which we'll call the least common multiple of the denominator, which I call the LCD, least common denominator of the fractions 1/2 and 1/3. So if you look at the 1/2 at the beginning of the left side and the 1/3 at the beginning of the right side, the common denominator is 6. So what we'll do is we'll multiply both sides of that equation by 6. And that's illustrated here in hot pink here, hot pink or red. So, and then if we multiply the left side by 6, the 6 times 1/2 is 3. But don't forget you have to multiply the 6 times the negative 4 as well, because that's two different terms on the left side. And so it'd be negative 6 times 4, because the minus in between them. And then the 6 times the 1/3, 2x minus 1, is just going to be 2. So it'd be 2 times 2x minus 1. So that's what we end up with. And remember, this is the same equation as the first equation, but it looks a lot better. And then we're going to distribute the numbers, 3 and the 2 on the right. So the 3 times x, 3 times 5 is 15, then 6 times 4 is just 24. So this is what we call combining like terms. We're distributing, and then on the right side it's going to be 2 times 2x is 4x minus 2. Now we're going to simplify by combining like terms. So the 15 and the minus 24 is a negative 9. The right side just comes down. There are no like terms on the right side. 4x minus 2 is 4x minus 2. Okay? You can't combine anything. There's not anything the same. Now what are we going to do now? Well, I think we need to get the x's on the same side to isolate the x. So what we're going to do is we're going to add 9 to both sides. And you're like, why do you do that? Well, because we want to get rid of that minus 9, because we want to get the x's on the same side of the equation. So if we combine like terms again and simplify, the 9's cancel, leaving me with 3x on the left, and then negative 2 plus 9 is 7 on the right. And again, this is the equivalent equation from the one before it. And the one before it was equivalent to the one before it. And it goes back to the beginning. So it looks a lot better than what we initially started with, doesn't it? Then we move on. We're going to subtract 4x. We're going to put the x's on the same side. So 3x minus 4x is negative x. and then 4x is canceled on the right, leaving with just 7. So we get negative x equals 7. So now we're going to divide both sides by negative 1, and x equals negative 7. And that should be the solution of the beginning equation. And it is, as long as there is no mistakes along the way. As long as we make a mistake along the way, negative 7 should work. Now, there are no domain issues here. There are no fractions that have variables in the denominator. There's no square roots or anything like that. So x equals negative 7 is a legitimate solution as long as we made no mistakes. But we're going to check it anyway. So we're going to substitute negative 7 for x in the expression on the left and the right of the original equation and simplify. And why don't we just simplify? Why don't we put it back in one of the middle equations? Let's go back to the beginning. Look at all the work that we did. Let's say we put negative 7 back into the 5th step. You could, and if it works for that one, that's great. But what if the mistake was made prior to that? So if the mistake was made prior to that, you would think you may have gotten it right. So you have to go back to the original equation to check your answer, not to the one that makes more. It's easier than the ones before that. So yeah, you have to go to the original whether it's complicated or not. So we put the negative 7 back in the left and right side. If the two expressions are equal, then the solution checks. And we do that here. So 1/2 x plus 5 minus 4 is the left side. We put negative 7 in there. And we get 1/2 times negative 2, because negative 7 plus 5 is negative 2. Minus 4 comes over. 1/2 of negative 2 is negative 1. And then negative 1 minus 4 is negative 5. So the left side is negative 5. We hope the right side is negative 5. Well, the right side is 1/3 2x minus 1. We put the negative 7 in there as well. And then negative 7 times 2 is negative 14. And it'd be 1/3 times negative 14 minus 1, which is a negative 15. And then 1/3 of negative 15 is also negative 5. So since the two expressions are equal, they're both equal negative 5, then the solution checks. And so the solution set is negative 7. So negative 7 is the solution. Okay? So this is how you solve one of the more complicated linear equations. Not all the ones that you're going to see on your homework are as hard as this one. Some of them are actually quite easier than this one. There are some that are a little bit more complicated than this one as well. And we'll be getting some of the more complicated ones in later videos here. This is the second video of 4. So probably the third video of 4, you might find some that are a little bit more complicated even than this one. Alrighty? So, but again, this may not be enough to help everybody out. So you can also look at the author videos that are coming. And you can also request student, what I call student request videos. Alrighty? And more information comes out later. Alright? So if you have any questions, as always, you call me. Give me an email. And you have a good day.